Hey there, future pharmacists. Welcome to this explainer, where we're going to dive into the foolproof mathematical tools you need to confidently compound mixtures without breaking a sweat. If you've ever looked at a compounding prescription and felt a sudden, massive wave of math anxiety, well, you're in exactly the right place. Today, we're taking that anxiety and turning it into absolute confidence. We're going to master a technique that is quite literally a staple in the pharmacy lab, ensuring your mixtures are perfectly calculated for patient safety every single time. We've got a super clear lesson plan today. First, we'll cover the magic of alligation, then move into medial for finding final concentration, followed by alternate, which is the famous cross method, and finally calculating exact quantities. All right, let's jump right into section 1, the magic of alligation. So, what actually is it? By the end of this explainer, this definition is going to be your superhero tool. It's used for calculating both final concentrations and the exact amounts of ingredients you need to create a specific final product. You see, in pharmacy, you rarely get a commercially prepared product that perfectly matches every single patient's unique needs. You might have a 20% ointment sitting right there on the shelf, but the doctor specifically ordered a 12% ointment. How do you get there safely and accurately? That is exactly where alligation steps in. It's the gold standard calculation method for mixing things like solutions, creams, gels, and ointments that share the same active ingredient but just sit at varying strengths. Moving right along to section 2, medial, finding that final concentration. Picture this. You're in the lab and you need to mix the contents of 3 distinct alcohol bottles. Sometimes we really just need to know what we end up with when we combine what we already have, right? Let's say our inventory looks like this. One bottle has 500 milliliters of alcohol at 40% volume by volume. The second is 200 milliliters at 60%, and the third is a much smaller 50 milliliter bottle, but it's a potent 70%. The absolute first step is also the easiest. We just add those physical volumes together. So, 500 plus 200 plus 50 gives us a total volume of 750 milliliters. But here's the real question. What is the actual strength of that new 750 milliliter pool? Now we figure out the proportional contribution by multiplying each bottle's volume by its respective concentration. This gives us its parts. Listen, you can't just average the percentages together. That's a huge trap because you have vastly different amounts of each liquid. Instead, you just multiply straight across. 500 milliliters times 40 gives us 20,000 parts. 200 milliliters times 60 gives us 12,000 parts. And 50 milliliters times 70 gives us 3,500 parts. It helps to think of these parts as the pure weight of the active ingredient that each individual bottle is contributing to your final giant beaker. To find the overall concentration, we just take the sum of all those parts. When we add 20,000, 12,000, and 3,500 together, we get a grand total of 35,500 parts. This basically represents the total active ingredient in the whole batch. Next, we divide that massive number by our total physical volume, which we know is 750 milliliters. It's essentially total drug divided by total volume. That's the foundational rule of finding literally any concentration. And boom, the math brilliantly gives us our final concentration, telling us that our mixture is exactly 47.3% alcohol by volume. And honestly, it makes logical sense, doesn't it? The bulk of our mixture was that 40% alcohol, so our final number shouldn't stray too far from 40, even with those smaller splashes of 60% and 70% added in. Pro tip, always do a quick mental reality check like that in the lab to make sure your math aligns with basic logic. Let's keep the momentum going with section 3, alternative, also known as the cross method. Now we're tackling alligation alternate, which is a vital tool when a patient needs a specific concentration that just isn't commercially available. Let's say we have 2 jars of cream on hand. One is 20% and the other is 5%. Our goal? We need to combine them to create exactly 250 grams of a 12% cream. This scenario is incredibly common in dermatology compounding. The doctor really wants a 12% cream, but the manufacturer only sells 20 and 5%. So you have to build the 12% yourself. This requires us to figure out the exact ratio of the higher strength and the lower strength needed to hit that target right in the middle. The secret sauce here is this highly visual cross-multiplication method. We place the available concentrations on the left, the desired 12% in the center, and follow the lines of a giant X to subtract. It's a beautifully simple visual layout. Think of it like a tic-tac-toe board. You put your high concentration, the 20%, on the top left. You put your low concentration, the 5%, on the bottom left. In the dead center, you place your target, 12%. Then you just draw diagonal lines connecting them, creating an X. Following the subtraction pathways diagonally across that X, we find the difference between 20 and 12 gives us 8 parts, and the difference between 5 and 12 gives us 7 parts. Now, the absolute key here is using absolute value, meaning absolutely no negative numbers. 20 minus 12 is 8, and that goes to the bottom right. 5 minus 12 is technically negative 7, but we just drop the negative, making it exactly 7 parts on the top right. We're solely looking for the pure numerical difference between our starting ingredients and our goal. Which brings us to our final step, Section 4, calculating exact quantities. Knowing the parts is a great start, but let's be real, you can't weigh parts on a pharmacy scale. You have to convert them into grams. To do this, we associate the resulting parts with the concentration on the opposite end of the horizontal line. So, looking straight across the top, our 20% cream makes up 7 parts of the mixture. Looking straight across the bottom, our 5% cream makes up 8 parts. When we add those together, 7 plus 8 equals 15 total parts. This means our entire 250-gram jar of cream is divided up into 15 equal shares. The 20% cream owns 7 of those shares, and the 5% cream owns 8. Now we can apply the rule of 3 to translate those abstract shares into actual weighable laboratory measurements. The rule of 3 is really just a simple way to set up equivalent fractions. If 15 total parts equals 250 total grams, then 7 parts equals X grams. By setting the visual cross next to the raw algebra, the path from an abstract ratio to a concrete weight becomes incredibly clear. We just take our target weight of 250 grams and multiply it by the specific fraction of parts for each respective cream. For the 20% cream, it's 250 grams multiplied by 7 divided by 15. For the 5% cream, it's 250 grams multiplied by 8 divided by 15. This step right here, this is where all your hard work pays off. You're directly converting the ratios you found from the cross method into actionable data for the scale. Drumroll please, the math reveals that to get exactly 250 grams of a 12% cream, we must perfectly mix 116.7 grams of our 20% cream with 133.3 grams of our 5% cream. And here's another huge pro tip for you. Always add your final answers together to double-check your math. 116.7 plus 133.3 equals exactly 250.0 grams. It perfectly matches our prescription target. If those numbers didn't add up to 250, we'd immediately know we made an error in our cross-multiplication, and we need to start over before ever touching a single ingredient. By mastering both medial and alternate alligation today, you've completely eliminated the fear of mathematical errors. You now know exactly how to find the final concentration of a mixed batch, and you know how to use the cross method to pinpoint the exact gram weight of ingredients needed for a custom order. The math is sound, the logic is verified, leaving only one question. Now that you have the tools to guarantee absolute precision, how will you use this confidence to ensure the safety and well-being of your future patients? Take these techniques, practice the cross method until it becomes second nature, and you are going to be an absolute pro in the compounding lab. Thanks for tuning into this explainer, and happy compounding.